True. Always true. True. Always true.
Good afternoon, ladies and gentlemen. I hope you guys are doing well. It's 1 a.m. again. Yeah, I think it's probably going to be that every single time because that's what the I do this. I tend to do this at about the same time every day. But yeah, good night. Hope you get some good rest, Pigetarian. Good luck at college. I gave up on that shit. All right, let's see. So last time we were doing this, we were dealing with just basic C strings and using not C strings. What was it called? It had a name. Character manipulation. Oh, yeah. So character manipulation. What we were doing last time essentially was look at our we were looking at the oh my god, dude, what's wrong with me? I can't remember how to word this. I'm just gonna open the fucking project. I don't know what's wrong with me. For some reason, I'm not able to think of it. But we were basically just writing into a character matrix and rewriting the character matrix using a new using a range-based for loop, I think is what it was called. And it's basically what we did is what we created is a line that would print the text that we had initially created, and then we created a second line that would modify that text. And I think in the example we did, we made all of the letters capital or all of the letters lowercase, that's fine. That's interesting. I'm curious whether we'll go into like trying to actually change whether we can actually change the letters themselves, if that's a thing. But if it is, then I don't know. But today we're doing C string manipulation, and also concatenation and copy. So we have about an hour of the video. I don't know how much of this is going to be practical. I'm hoping a lot of it is, because I really enjoyed doing the practical stuff that we did yesterday. And yeah, let's just get this show on the road, shall we? Get it all. There we go. All right. C string manipulation.
In this lecture, we're going to look at the facilities from the C++ standard library to play with C strings. All of these are going to be living in the C string library. You can go and check it out at CPP reference. And we're going to start and look at a few examples of some of the things we can do with this library. I mean C string. The first thing we're going to look at is an example of how we can check the length of a string. Here we have a character array called message1. It is a character array, and you see that we made it const. We also have another array that is pointed to by pointer. You know that if we do things like this array is going to decay into a pointer, and there are a few things we can do with it. For example, we can't use it with std size, and we can't use a range-based for loop to loop through this message2 thing here. But strlen is going to help us check the length of this thing here. So we can use it. For example, if we do std strlen message1, we're going to get the number of characters in this string here. This is not going to count the null character though. So the null character that is implicitly added in by the compiler.
Wanya, how you doing, Tara?
You're going to see this in a minute when we hit Visual Studio Code to play with it.
I saw that you uploaded a video as soon as I started streaming.
It can work regardless of whether you are using a row array like this or even for pointers like this, and it is really cool. So we can use it like this. We're going to get it printed out. Please know that we can also use the size of operator to get the same thing. So it is going to work almost the same way, but the size of operator is going to include the null character. You need to be aware of this. The good thing about
that's in the fucking video. Oh my god.
It still works for decayed arrays. So if we use
I really want to go back to sleep. I understand.
The correct output, we're going to get the number of characters in here, which is really cool. And we can also try and print out the size of message2, but here we're going to get the size of a pointer printed out. Okay, that's how strlen works. It lets you evaluate the length of a string. Here is another example, and it is strcmp or string compare. It is used to compare
string
strings.
Compare.
What you're going to do
but I cannot.
Is
why not?
Give it two strings.
You got something to do?
We should be exact. And one is this guy here, LHACE or left hand string. I think that's what this stands for. And we're going to give it a right-hand string. And by the way, these signatures are copied straight from the documentation so that we can look at this in one slide to make it really easy to follow. This is going to return a negative value if the first guy happens to come before the second guy in lexicographical order. So it is something like A comes in front of B, C comes in front of D, or something like that. If the two strings are equal, it is going to return 0, and it's going to
discipline. This is the only way I'll get the manga done.
If the first guy appears after the second guy.
We are the habits we build, right?
Try it out. We have two strings, Alabama and Blabama here, and they are
Alabama and Blabama
arrays that are pointed to by these two pointers, string data1
It's
and string
Alabama
data2.
and B
And we
Alabama.
can do something like this below here. So we're going to print something out. And we're going to say std string compare, and we're going to pass in the first string and the second string. For now, I want you to pause a little bit and try to guess what we're going to get printed out here. The first string is...
So here, he wants us to pause and figure out what we're going to get here. So here we're getting, what is it? String compare, string data 1, string data 2. Alabama, B Alabama. So we're comparing the two things. So what I think will happen is this one will print just comparing A Alabama and B Alabama. And then this one that actually does the comparison, I think will print out just should just be a -1. But it could also be that it's -1 and then a bunch of zeros because it's checking each letter and how different they are. I'm not 100% sure on that. Turns negative value if LHS appears before RHS in lexicographical order. Yeah, it's essentially telling us about the where it would be on like a Caesarian cipher, I guess, kind of, sort of, not really. But it's like the first letter is a -1. I'm thinking that it's just -1 and then a string of zeros because it's no difference, no difference, no difference, no difference, no difference, no difference.
Is Alabama, the second one is Blabama, so the first one comes in front of the second, and we see that we're going to get a negative value if the first guy comes in front of the second guy. So Alabama comes in front of Blabama, and we would expect to get something negative from this thing we are doing here.
So is it just going to be the -1?
Change them up a little bit, you see that Alabama still comes before Alabama. So we're going to get
Alabama and Alabama.
and we can change these things up to see what we get. It is really simple if you know how to use them. We can also use another version.
I kind of want to see what it prints out,
which is going to let us specify the number of characters that we want to compare. We can specify that we want to compare n characters. In this case, it is 3 characters, and it is going to compare a section of the strings that you specify as a first and second parameter here. So for example, if we change string data1 to be AAAIA and string data2 to be AAANCA, and we are comparing 3 characters in here, so we are comparing AAA to AAA, we're going to see that they are equal.
So it should be 0 then.
0 printed out here. You're going to see that this
will be interesting to test
when we get to play with us in Visual Studio Code in a minute. We have a facility that we can use to search in a string and search for a character. The facility for that is strchr, and it is going to find the first occurrence of a character in a string. And the documentation for this is right here. And please note that this example is actually copied straight from the documentation. Okay,
I mean, that's interesting.
The message here. It is a character array, and it is.
I'm working on the page just after he gets home with Pippin and Tub, and the other veggies are causing chaos. Nice.
Character that we are looking for, and the result is going to be.
Can't wait to see it.
The result character array here, and we have a variable called iterations that is going to keep track of how many iterations we did to find our target here. The way this guy works, it is going to return a pointer to what you find. If it is found, for example, in here, if we find this first t, this function here, or this facility, is going to return a pointer to this first t here. If it doesn't find what
it returns
we want,
a pointer.
It is going to return a null pointer. That's how it works, and you can see that in the documentation here. We are going to take advantage of how it works in this while loop here, and the way you use this facility, you give it the string you want to search in, and you give it the character that you are looking for. So if we look at how it works in the while loop here, we are going to call the function, and we are going to store the result in our character pointer here. And if we go inside, we're going to hit the first character here at the first iteration, so we're going to find this t here, and when we find it, the result of this is going to be stored back in result here. I hope this makes sense. So we're going to.
I'm not gonna lie, it's kind of going over my head a little bit. I'm hoping that practicing and actually attempting, seeing what it does,
And
helps
after we
me
do that, we're
understand
going to increment the
better.
iterations. So we should have one iteration by now. And we're going to jump into the loop again. So the string we search in is going to be starting from R here. So we're going to try and find an uppercase Tn, and it is going to find this uppercase T here. So it is going to point to it, and the pointer to this T is going to be stored in this result here. Okay, and we're going to jump into our body here. We're going to say that we found this T. We're going to print it out, and we're going to increment result. If we increment result, now result is going to be pointing to the H here. Okay, and we're going to say how many iterations we did to find our thing. We will have printed out the T that we have found, and we're going to jump to the next iteration, which is going to be searching for T in the remainder of the string here. It's not going to find it, of course. It's going to return null pointer, and the test here is going to fail, and we're going to fall down here and say how many iterations we found. I realize this example can be really confusing.
Yeah, no
And we're
kidding,
going
it's
to
a little
try and
confusing.
explain it again when we hit Visual
Sorry, I'm
Studio
coughing
Code.
something
For
fierce.
now, know that this
I don't know how to
facility
read.
can help you find characters in a string. That's the message here. There is also another function that helps you find the last occurrence of a character in a string. For example, here we have a character input. It is a path to a file on some Linux system or Mac system, and we have an output character pointer, which is going to store the pointer to the character that we found. Okay, if we find the character, we're going to store in the pointer to that character. If we don't find it, we're going to return null pointer. I think that's how this thing works. So what we really want here is to hunt for the file name in this path here, and this is really interesting. So we're going to search for the backslash, the last one in this string here, and it is going to find this guy here because that's the last occurrence of a backslash in our input string here. Once we find it, we're going to get a pointer to this guy stored in the output character pointer here, and we're going to print it out. What we're going to do, we're going to use pointer arithmetic to move this pointer to the next guy because that's what we really want. We want to print starting from the H here, and that's what we're going to get when we print this out. Now that we have looked at all these examples, I think it is time we headed to Visual Studio Code and
Yeah, I'd like to test and
okay, here
practice
we
with
are
some of this
in
stuff because
our working folder. The current
I'm having a hard
project
time kind
is
of wrapping my
C-string
head around what
manipulation.
exactly
That's what we're going to
we're
work on.
doing.
We're going to copy our template files and we're going to put that in place. And we're going to open this in Visual Studio Code pretty quick. Let's include C-string because that's what we're going to be using. Many of the things we're going to be playing with in this lecture are documented in this piece of documentation here, so you can come here and get more details than we could even cover in a course like this. Let's bring this up a little bit, and we're going to go in our main function and put in the first piece of code we can play with.
Oh geez. Oh geez. Okay. Let's do this shit. So const char mess. Oh god, my fucking throat. Ah. Message 1. The sky is blue. And then we have our const char message. Oh wait, this is the pointer. Message 2. The sky is blue. Array decays into pointer when we use const char. I'm kind of curious what that means. Message 1 and then message 1. And then we end line. The sky is red. Ah, the Lord is returning. That would be terrifying. I'm not going to lie. So, std string length. Find the length of a string. I mean, that makes perfect sense, right? Real arrays and those decayed into pointers. Now, I'm not quite sure what the word decay means in this context. It doesn't really make sense to me intuitively. Use const char. So then we get all this good shit. String length ignores null character. I assume that, I'm pretty sure that it's referring to this. So we can get cout string length message1, and then it just prints out whatever the thing for that is. And then we go end line. This one includes the null character. I'm gonna say size of includes the null character. Then we have our cout, and then it's size of message1, and then we do size of message1, and then we go to our end line, and this one is string length still works with decayed arrays. Decayed arrays, huh? Message2. So if my understanding is correct, the way that it's being said here, where it's talking about the pointer decaying into an array, or the array that decays into a pointer, is that this should be the same functionally. Like string length, from what I understand, should function the same on the pointer and the original without requiring me to dereference it. And this one says it prints the size of the pointer, which I'm not 100% sure why we're doing that, because with the pointer, I mean, it seems like we covered that. Oh, whoops. Oh, wait, never mind. Oh, wait, you know what I didn't do? Didn't bit shift. I always forget those. But it seems like we covered that all the pointers are pretty much are the same size and take the same amount of data, which is what size of is for, if my understanding is correct.
The strlen facility is going to find the length of the string, and it's going to work regardless of whether you are using a row array like this, or even if you are using a character pointer to point to your array. And this is pretty cool. So here we have
So it treats
strlen
them the
message1.
same.
We're going to print that out. We're going to print how many characters we have in this guy here. We're going to also use the size of operator to try and compare these things. But please note that the null character is going to be included if you use size of here on a row array. This is very important to know. But
Yep.
one interesting thing about strlen is that it is also going to work if you are storing your array in something that is pointed to by pointer. So even decayed pointers are going to be usable here, and this is pretty cool. So we can also try and print the size of message2, which is pointed to by a row pointer, and we're going to see what we get. But we know that we're going to get the size of a pointer because that's what it really is. Message2 here is just a pointer. Okay, let's close this on the left, and we are going to bring up our terminal and try and build this with GCC. We're going to do that. So we're going to use GCC to build this. The build is going to go through, and we're going to clear and run rooster again. And this is going to give us what we want. strlen message1 is 16.
So that has the number of characters. Size of includes.
Size of is also going to.
Okay, so yeah, because size of gets this character that we don't actually have written in this, and then message2, the one that we initialized as a pointer, has the same amount, but then it also has the size of. So it still has the string length, but the size of for the message2 is still only 8 because it's a pointer, and not a and it's not actually a string. That's interesting.
Count the null character strlen message2. You see that it works even if we have a decayed array that is pointed to by a pointer. And this is really useful if you happen to need the size of an array like this. You can use strlen and you're going to get the size of data in there. But note that the null terminating character is not counted if you use strlen here. And size of message2 is going to be 8 because that's the size of a pointer on our system here. So note that this guy is just a pointer. Okay, that's the message here. We are going to comment this out. The next thing we're going to look at is strcmp, which can be used to compare strings. So it works exactly like we said. It's going to return something negative if the first string happens to come in front of the second string in lexicographical order.
Lexicographical order. That's a really fucking weird word. I've never heard somebody say lexicographical. So this is our string comparison. String compare. String comp. Signature. Int string comp. Const character left hand. He uses a word. He used a word for it already. Const char right hand. I'm gonna change left hand sign. Left hand and right hand. Oh, what you doing?
Negative in lexicographical order.
Ah, must have been.
For example, here we have a few variables. We have
Yeah, that must have been an editing error.
and blabama. They are strings pointed to by pointers, so they are C strings. And we have a couple of other strings stored in row arrays like this. And by doing this, I want to prove that this facility is going to work regardless of how your array or your C string is stored. So we're going to use that here for our C string pointed to by pointers. We're going to try and compare whatever is
Actually,
string data 1.
So I wrote alphabetical, but I think lexicographical is actually important because I think lexicographical actually counts a difference between capital letters and lowercase letters. So like if you have a capital A and a lowercase a, I think those will return different values when you compare the two words that it does. All right, let me get some of this stuff written in. And positive value if LHS appears after RHS. And we assume that it's lexicographical still. There's no reason to write that in. All right, so let's create an empty line. I suppose for for our own sake, for readability. And we do std string comp, and then we do to basically tell us what we're doing. So we have our const char pointer string data 1 Alabama. Now he has spaces in between. I don't know if that's necessary. STD is still funny. It'll never not be funny. Let's try string data 2. And this one's going to be Blabama. I don't think those spaces are necessary, but I'm trying to make sure that my stuff looks like his stuff. String data 3. This one's a character matrix. And it's the same thing. Alabama. Then we have string data 4. Another character matrix that we have called Bilabama. And then we're printing, oh my gosh. No comparison. We're printing our comparisons. So then here we're doing std cout. And we have our std string comparison doing like that. And then it's well, it's covered up is what it is.
With string.
There we go. So we have our string data 1 and then some text like this, and string data 2 with some more text, and then it's always so confusing to do the text stuff. And then this is continuing std, and then we do our actual comparison, which has string data 1 and string data 2, std end line. And then we have our second comparator, our second comparison, which is std string comparison. And we have string data 3 and string data 4, as well as our std. And this is the actual comparison where we use string data 3, string data 4. So what this is supposed to do, from what I understand, so we have, first it prints an empty line, then it prints this. Const char, we initialize a pointer called string data 1, and it contains the address for something called Alabama. I assume that this is a string. Or no. Looks like it's a matrix of some sort based on the way that it is. And then we have another one called called string data 2 and Bilabamo. We create a character matrix called string 3 initialized with Alabama, and another character matrix with string 4 called string data 4 called Bilabama. And what we're printing is a comparison first between the two strings and then between the two character matrices. Actually,
String data 2. String data 1 has Alabama. String data 2 has Blabama. So if we compare these guys, we expect to get a negative value out of this thing here.
we would expect that.
strcmp.
I'm curious
because
how the
Alabama
comparison
comes in
with
front
this first one
of
is going to go.
Blabama in our alphabet. So A is in front of B. So we're going to get a negative value out of this. And we expect to get the same thing in the second example here, which is going to be using what we store in our row array. So make sure you understand this, and we're going to try and build this to see that.
So I still think that it's going to do... I'm not sure whether it's comparing each letter and going like, okay, this one's -1, this one's 0, if this was like B, maybe it's like +1. I don't know if it's doing like that or if it's doing something else. Let's build it. Let's build it. I'm not sure. I need to see. I need to see the results.
That it passes through our GCC compiler. The build is good. So we're going to clear and run rooster, and you're going to see that we get a -1. I want you to play with these things and try and change, for example, the A to a C and see what you get. Okay, we're going to try.
So they both... Okay, so the string... I think that the way this is done is confusing. I'm going to just... I kind of want to just call this... I'm not going to... I don't want to fuck with it too much. I'm basically just going to ignore this. This is the first one. This is for the pointers, and this is for the matrices. So I kind of want to change this to a lowercase a and see if that changes anything. Because I imagine it does. It could... I might be wrong. And then in this one, I think I'm going to change this last one to a B. So we know that there should be two differences here. So let's run task. So this one is the lowercase a makes this makes it so that so that Bilabama technically comes before Alabama, because the capital B is lexigraphically before lowercase a. And I would imagine that if I made this Zilabama, it does exactly the same thing there. This one, it looks like it looks like the only thing that it really cares about is the first letter for either of these. Like with the strings, that kind of makes sense because, or no, with the strings, with the pointers, that kind of makes sense because with the pointers, it's like, oh, here, it's pointing to a place in data, and then those, when we tested the pointers before, it would give us the first letter of a character matrix every time. So I'm not surprised that it doesn't really care about any of this other stuff. Like this is probably still going to give me a -1 just because the first letter lexigraphically comes before the first letter of the other one. So this is still going to be a +1. This one, I think, even though there's another difference here, it's doing it's going to stay -1 because, I mean, we could change this to I don't know. If this is A, it doesn't matter what this is, Because I'm pretty sure. Hey, what if I make it a 2? Does that do anything? Does that count towards anything? Do numbers lexigraphically come before letters? Let's find out. So I'll clear this. So here, so this one is still okay. So yeah, I'm still right on this one. The Z is this all capital letters lexigraphically come before all lowercase letters. And then numbers, interestingly enough, also lexigraphically come before this come before uppercase letters. So then if I make this I mean this is a little bit a little bit pointless, but if I make it like if I do like this, it's as far away from they're about as far away from each other as they're on different sections as could be. So then let's make this one. So these two are going to be totally equal. This if we run it like this just returns a 0. We know that. So let's change this one to a. Let's make this one B. And then we go. Oh, no. Terminal run task. Yep. 4 comes before Alabama. 4 comes before lowercase. We knew that. A comes before B. We knew that. But then if I change this one to A, B, C, D, E, F, G, H, I, J, K, if I just make this an L, Alabala, then this one, it should, actually, no, what am I doing? Do it like this. Do this one to Alabalb. If we do that, then suddenly I think the other one should be, this one should be a positive 1 now. All right, cool. So now we can organize letters. Now we can organize things lexigraphically. That's kind of neat, I guess. I'm not so sure when I'd need to know whether one thing comes before another lexigraphically, to the point where I would need to code that. I feel like you can tend to just look at those kinds of things. I'm sure that there's a reason that you would need your code to know that. Anyways, let's continue.
World. But before we do, try to expect to see what you get. C comes after blabama. So if we look at this description here, we should get a positive value because the first guy comes after the second guy in lexicographical order. So we should get a positive value for the first thing that we print here. Okay, let's build and see if that's the case. We're going to build successfully. We're going to clear and run rooster. And you see that the first guy prints a 1 because klagama comes before blabama. And the second one is going to still be a -1 because we still have whatever we had before in there. Okay, this is how you work with these things. Let's turn this back to Alabama.
I mean, this makes sense because this is all stuff that this is what we just tested.
And we're going to keep working on this. In the next piece of code, we are going to try and modify whatever is stored in string data 1 and string data 2 and print the comparisons out. For example, we have Alabama and Alabama. And by the way, we are able to modify that because it is a pointer to a string. And notice that this is not the const pointer, so we can really change where this guy is pointing, and that's what we are doing here. But we can't do that with string data 3 and string data 4 because these are arrays, and remember, you can't change where an array points. So this is going to compile nice, but if we try and do the same thing with string data 3 and string data 4, let's do that. You're going to get a compiler error. So we're going to put this guy here and say 3 and 4. And we should see Visual Studio Code complaining here.
Starts freaking out.
Because this is not allowed. You're not allowed to make an array point to another location. And this is just another character array or const character array in memory that we want this pointers to point to, or this array to point to, and this is not possible.
Alabama.
So we're going to get a compiler error if we do this. This is something I wanted you to know. That's why I set up this example here. So if we run this, we're going to see the first line of output here, or I think I should comment that out. Or let's not comment it out. Now, if we run this program, we're going to get the output for Alabama and Alabama printed out. And Alabama comes after Alabama, so we expect to get a -1 because the first guy here comes in front of the second guy, so we're going to get a -1 out of the thing we are doing here. Let's try and build with GCC. The build is going to be good, so we're going to clear and run rooster, and we're going to see that we have a -1 here. Alabama comes in front of Alabama, so this is cool. So we can try and put in many other examples for you to play with. I am going to do that because I don't want to type all these things. And we're going to print the result out. For example, we put in India and France, we put in Kigali and Kigali, and we're going to get things printed out here. So let's build this so that we don't waste time. We're going to clear, and we're going to run rooster, and we're going to see that we get these things here. Alabama comes after Alabama, so we get a 1.
Alabama.
India comes
Alabama.
after France, we get a 1.
All right, so we got all of that stuff. This kind of makes sense.
Kigali, and we get a 0. You can try and put in whatever you want. These are just a few examples for you to play with. And by now, I hope you really understand how this function works, or this facility works. So we're going to comment it out, whatever we did here. So we're going to comment all this out so that we don't have noise output in whatever we want to do next. And what we want to look at next is this function here, which is going to compare strings in the same ways, but we're going to tell it to compare however many characters in the string. And you see that my string here has been commented out. I can quickly take it and bring it down here. Let's do that. I can't find that. Let's find that and copy it down. And we're going to find them here. So I'm going to find this and bring that down here so that I can compare these things. So let's come down here and print and put in our declarations for these strings. And you see that Visual Studio
size
Code is
T
now.
and
So what we're going to do is compare a set of characters in these strings here. Okay, so we're going to compare any
an empty line
in our strings. So we're going to compare Allah to
we're going to compare Allah to Bila. All right, let's continue this. Hold on. STD cout. STD stern comp. This is just for us. This because we're initializing a few things here. Here again, we're creating a pointer that to a matrix with this text in it, with each of those with 2 different names. And then so here we're doing std end line, std cout, and then this is where we're actually doing it. Std stern comp. And this one is like so. So here we have string data 1, and then we're creating a comma here, and then we have a string data 2, and then we create a comma here, and then we're changing it to n, or we're comparing n characters. So, like so, and then we're creating more text. So then we come to here, bit shift a little bit, std stern comp, and then we do string data 1, string data 2, n. Then we have our std end line. Okay, so the way this one is written, it's doing the same thing as before. where what we did up here, where it's comparing two strings, right? And it'll, with this one, it should still return 0 because they're both Alabama. So the ALA will get changed, and we can change this to like, we can change it to 4 or 5, but it doesn't really matter unless we change any of those things. So let's change this to, let's get a, I think if we do like this, it should be a negative value. Because it'll be Allah versus blah, blah versus Allah. And then we do this. And here we can change, because we're pointing to two different strings in memory. We're pointing to two different matrices. So what we can do is we can just kind of make this whatever, and it holds whatever value. So if we do like this, like the example he has, I ding fucking pillar man ass text. Hellabama. So then here it's copy this whole thing, and we do like so. I need to indent all of this. And then, so what this does, this will modify the matrices that we've created, that we're pointing to up here. So, and replace the text that they have, and it'll be, so this should also, this one should return 0 because it should only be testing these three. So let's give it a shot, shall we? Terminal, run task, G++. Creates another empty line, and then we have our Alabama, B-Alabama 3, so the -1, and then our and we're only testing the first 3, so this is 0. And another thing that we could do is that we could go back and change Alabama. We could make these the same, and then we could make this Alabama for just for shits and giggles, and this one then should return 0. So let's do that. Run task G++. Yep, and because we're only testing the first 3, it doesn't care about this 4 at the end. It doesn't care about anything after ALA, and it works just fine, and it returns a 0. I think that's good.
Blah here, and Allah is going to come in front of blah, so we're going to have a -1 printed out here. But if we change the strings to AAA and AAA here and compare the first 3 characters, we're going to get a 0 printed out because the first 3 characters are equal. And again, the special thing about this function is that it allows you to specify a number of characters you want compared in these 2 strings. So you can
Does
say,
it let
I
me
want to
compare
3
sections?
strings. You can say, I want to compare 4 strings or 5. Just make sure that you don't go over the size of the string. And if you do that, it's not going to make sense what you are trying to do here. If we go down here, we're going to change n to 5, and we're going to be comparing all these things in here. And we're going to get that the first one comes in front of the second one because I comes in front of n in our alphabet. If we change
That's
the
another
data
thing that
to
might be worth
O
testing.
here and n, O is going to come
We
after
can do
n, and we're going to get a positive number printed out here.
n
We're going to try and
equals
run this.
5.
So let's run the task to build with GCC. The build is going to be good, and we're going to clear and run rooster. And we're going to see that Alabama comes in front of Blabama because we are comparing the first 3 characters. If we have AAA in here and we compare the 3 characters, you're going to see that they are equal. We get a 0. If we change I and n here, we're going to get a -1 because I comes in front of n.
Yep.
If we use O here and n, we're going to get a 1 because O comes after n. This is really simple to understand. Now that
Makes
we
perfect
know how
sense to
to use
me.
the first version of string compare, this version is just going to allow us to specify how many characters in the string we want compared. So we're going to comment this out, and we are going to go down and do another example that allows us to search for a character in a string. And the method we use to do that is std_strchr. So this guy is going to find whatever target you want to find, and if it finds that, it's going to return you a pointer to .target. If it doesn't find it, it's going to return you null pointer. So we set up an array here, and we store that.
Code stolen from the docs. That's kind of funny. I didn't see that he had written that. Here, code stolen from the docs. And then it's the std cout. It's empty line as we like to do for our readability. And then we have std string character, I guess. I'm curious why it's called that instead of just like, I don't know, search or some shit. We have a link to our doc. We might as well do it. Yes. en.cppreference.com/w/c/byte/stringer. We use to find all the characters one by one. Yeah, this lets us search for specific things, but it's not just characters. It's very specifically that like the exact same lexicographical value. Because like A is not equal to A. B is not equal to B. C is equal to C, and D is equal to D. Like this is an important concept to understand, I think. Because this is not just finding the same character. I feel like that's just kind of been glossed over here. Which, I mean, we found out about it because we tested with like numbers and other shit. We use this to make all the characters. Okay, and then this one is const char pointer, calling it string. Try not. Do or do not. There is no try. And then we do can make this a const pointer to prevent users from making it point somewhere else. That's fine. Miss Tron, please name me something that shows up first. Okay, then. Pretty much. It's like, okay, you want to be first in line? Okay. Step right up. So then we'll make this one char target equal T. So like he made a point to, he did mention this. He didn't make a point of this, but he did mention that like when we in the lecture portion that when we search for this, we're going to find two results because there's only two capital T's. But that doesn't even but I feel like he's glossed over that it's not going to find these two. Like there's three other T's in here that it's not going to find. At least during the lecture, I feel like he glossed over that a little bit, and I'm sure he'll mention it here, but it's still. Result is strength. Well, I say strength, but it's actually probably supposed to be strength. Int iterations. And then we're going to create a while loop by the looks of it. So we have while result equals std str chr result target is not equal to null pointer. Std cout found target, and we have this on another line for some reason. Starting at result \n. Oh boy, I hate this. I don't like how this looks at all.
In a location that is pointed to
I need
by
him to scroll
the
down.
pointer to character here, and we say whatever target we are looking for. In this case, we want to find this t here. We are going to set up another character array that is going to store our result. The result is really going to be a pointer, which is going to be pointing to something valid if we find the target, and it's going to be null pointer if we didn't find the target. And we set up another variable which is going to store how many iterations we did. We should really
Wait, back up just a little bit.
if we find the target, and it's going to be null pointer if we didn't find the target. And we set up another variable which is going to store how many iterations.
Okay, so this is the rest of it. So then here we're incrementing. It's increment result, otherwise we'll find target at the same location. And then here it's plus plus result plus plus iterations. Std cout iterations, and then go with our iterations. Okay, so this looks like it's the complete thing. So first thing that's going to happen, we're going to print out an empty line. Then we're going to print out our thing basically saying this is what we're doing. This is for us. We've created a constant character pointer. So it's pointing to a character and it cannot be edited. Called string. str. This is the contents of this I guess it's a character matrix, right? That it's pointing to essentially. No, it's not a matrix. It's just a string. Fuck it. And then we create a target. We create a character called target, and we create a constant character pointer called result, which is equal, which contains this this pointer. Wait a second. What the hell? So we have two pointers. So then while result is equal to this value, result target. Oh gosh, what the fuck? I'm trying to understand what the fuck I've written. Which, to be fair, it's stuff that he's copied. What am I trying to understand here? So we have our result. Result is this pointer. which points to this, which points to this text. Or no. Yeah, so result points to this. So while result is equal to this, when we do our string searcher. This isn't, yeah, no, that's our comparison from before. So then result. So we're searching result and comparing against. No, that's not what's happening at all. Oh God, what the fuck is going on? Maybe he explains it and I'm just not understanding.
Iterations we did. We should really make this an unsigned integer or size t, so let's make that here. And we're going to loop here. So the first time we loop in here, we're going to call this guy. We're going to say, I want to find a t and result here. And the result is going to be
I want to find. Hold on. Let me make this size t so that we can be the same. If we're fucked up, if we're all fucked up in the same way, we're not fucked up. Let's see. So we're searching. I have 9 panels left of chapter 1. Hell yeah, man. Kick ass. Keep at it. Let's see. So we're searching for. All right, we're searching. Okay. So we're searching in here. strchr. We're using our searcher. We're searching in here, which, because that's this one, is this one. So we're searching in here for this. So we're searching for a capital T. Then we find it, and it says starting at, and then it shows our thing, and then it ends the string. And then we increment our result. So we have to go up one more. So here it'll be like essentially at index 0, and then we increment up, and then we add to our iterations, and it tells us how many iterations it's done. And then because if we don't increment our result, it'll just immediately find this one again. And then we go through. So the second time through, it should find this one. And then when we find this one, it'll do that one, increment our result again, and so that we don't search this again. And then it'll increment our iterations, and then it should go to the end, and then we get out of our little loop here, and then it'll tell us how many iterations. Okay, I think I'm understanding it now. My gosh. Terminal, run task. Let's give it a shot. So stdcr and our empty line as expected. Found t. We didn't put a space somewhere. Found t starting at try or try not, do or do not, there is no try. So it prints the whole rest of the string. And we found another t starting at there is no try. There are 2 iterations. All right, let's add that space in just so that it looks a little bit better. Clear, run. I think it's a little bit weird that it'll I think it's kind of okay. I think it's cool that if we do the result after we've found the thing, it'll print only the text that it hasn't printed that we were at. But I also think it's a little bit weird that we're doing like, oh, found T. And it says found T starting at. And I mean, there's obviously the one that prints the whole string, and then there's the one that prints only the last four words.
Pointing to this thing here because we did the assignment here. So it's going to go in and try to find a T. It's going to find the guy here at the first index, and the test here is going to succeed. When it succeeds, it's not going to be equal to null pointer. It's going to be pointing to a valid pointer, and it's going to succeed and return the pointer to be stored in result. After this guy returns, the pointer is going to be stored in the result here, and that's going to be a pointer to this T, and we're going to jump in the body here. I really want you to understand how this thing is going to work. Once we get in the body, we're going to say, we found our target. That's going to be our T printed out, and it's going to start at this location. Okay, and we're going to print starting from the T here because that's what our result here is pointing to. After we do that, we're going to increment the result to make it point to the next character. If we do that with pointer arithmetic, now we're going to be pointing to the R in here. I hope this makes sense. And we're going to increment.
Yeah, okay. This is the thing that I kind of didn't understand what it was doing, and it's because so if my understanding is correct, because we've created a constant character pointer here, it has the implicit, I think, null pointer after the string. So that's kind of, so it's not like it's just, it's not like once we get to the end it points to junk data. I'm pretty sure, if my understanding is correct, it has essentially not the I don't remember the null character, but like because it's a pointer, it's doing it does null pointer. I think I'm understanding it. I kind of want to
increment our iterations.
I kind of
So
want to test it.
we have done one iteration, and we're going to try and run this again. And by the time we get in here, we're going to have this string here in which we are searching for a T. And a T is going to be found starting at this second T here, the there here. And it's going to find it. It's going to store the pointer to it to result here, or I should say the search is going to be successful, so we're going to find the pointer to this T and return it from this function here. And the pointer is going to be stored in our result pointer here. We're going to jump in the body, and we're going to print, we found the target starting at this T. We're going to print that out. And stdc out is going to print until it meets a null character, so we're going to print this thing through the end. And we're going to put a /n, which is going to move us to the next line. After we do that, we're going to increment result, and result now is going to point to the H here.
Right.
And we're going to increment iterations. Now we're going to have done 2 iterations by now, and we're going to run the loop again. This time the loop is going to fail because starting from here, we don't have a T. And this function is going to return null pointer. And this test here is going to fail. Okay, we are going to return null pointer.
Our test fails,
null
and then
pointer
we
is not
come
going to
out
be different from null pointer, so this is going to fail. And we're going to fall down here and say how many iterations we're going to find. So in total, we're going to do 2 iterations, and we are going to find 2 T's, and we're going to print whatever we find here. Make sure you really understand this. And I put in this example on purpose because it is a little complicated, but it is going to really bring your game up in how you use these functions from the C++ standard library. And you really need to know this. If you have any problem with this, be sure to ask me. I will do the best I can to help you out. So we're going to build this and run this. We're going to build.
So that should build exactly as ours does.
And run rooster. And you're going to see that we are looking for T. We are going to say we found T starting at the T.
Okay, so our understanding of this is kind of solid now. So what I want to think of now, or what I'm going to try, I'm going to edit this this target here. I'm going to change this to a lowercase t, I think, because I think what it'll do is it'll Like, we used a capital T, and those are there was only two, and they were the first letter of each word. I'm pretty sure if I do a lowercase t, what it should do is it'll say that it found a T starting at, and then it'll do. I think it just doesn't print these letters. Like I shouldn't print those letters, but I think it'll do T period space, and then the rest of the string. I think it should print essentially this part, and then it should do a second iteration where it prints this part, and then it should also do a third iteration with just the word try. So let's run that real quick. Let's do that to a lowercase t, run task, G++, and found T starting at T, do or do not, there is no try. Found T starting at T, there is no try. And then found a T starting at try. 3 iterations as predicted. And this is working exactly. Okay, my understanding of this is complete now. I know what the hell's going on here. I know what's going on. I had a dream last night that I was school staff and the kids thought one classroom was haunted, and then I saw the ghost and I saw a single school desk hidden in a secret wall compartment. Oh man, that reminds me of a Goosebumps book I read once upon a time, where basically these kids got stuck in like a colorless dimension that was just the school, and they weren't able to get back. And it was like the entrance to this dimension was in like a locker. It was freaky. It scared me as a kid. It's one of the few Goosebumps books that I remember being like, "Oh wow, that book was like actually scary to me as a kid." Like the scary doll and like monsters in the basement is like kind of. I mean, those were they were scary insofar as like it was horror, and I was like, I didn't do a whole lot of horror. And then the skeleton is there, and he's scary pretty much. I did think that there was one that was like I think it was called Say Cheese and Die. That one was good. All right, let's continue this.
Here, so we're going to say tried. Okay, we're going to print all the message out, and the second iteration is going to find T starting at this location here, and we're going to do 2 iterations in total. We're going to comment this out, and again, if you don't understand this, please go through it again, and if you still don't understand, be sure to ask me. I am going to do the best I can to help you out. And some of you might be asking, why did we go through the trouble to store this guy in result? Why don't we use str in the first place in here? And the explanation I can come up with is that you don't really want to modify this guy here, because somebody is going to look at this thing and say, this is the message I have in str here. But if you try and modify this in the loop, it's going to be messed up because you're going to be incrementing it and doing all kinds of crazy things on it. So you don't really want to modify this. So a better way to even do this is to mark this as a const pointer. And we know how to do that. So we can say const here. And if you even try to increment str somewhere, you're going to get a compiler error. So let's make sure we see that. For example, we try and do plus str. We're going to get a compiler error because this is a const pointer by now, and this is much safer. Okay, we're going to comment this out and show you something that might throw off many of you guys. So we're going to comment this out, and I am going to bring that in. Okay, let's go down here, and we are going to do basically the same thing, but we will try and use str in the first place here. Okay, this is how we're going to do this. We're going to have our string. We're going to have our...
So we're doing the exact same thing by the looks of it, with minor difference to we're gonna do like this. All right, so then we can take this down, pass it around. 99 bottles of beer on the wall. Okay, we can get rid of this line and this line. And then here, instead of being a result. Let me change this to null pointer. We can change this to capital T again. This one's a const char pointer, const char result, size T. He's probably going to change that one back. So this one we're doing to str target found starting at result. And then here we're changing this to string str. Okay. So this looks like it's doing it just from here instead of doing it through a pointer, which he said that the pointer was like the safer way to do it, which kind of makes sense because you're pointing at a place in memory rather than at a particular thing in data, I think. Well, but no, this is also a pointer, so I'm kind of I don't know. I mean, it's like it's not like a you know, let's listen to him give the explanation so that we can understand better. Because I'm kind of like leaping ahead and making assumptions that I don't really need. I don't really need to be doing that. The pooter.
Target, we're going to have our result here, which is equal to null pointer. And we have our iterations, which is an integer. Let's make this a size t. And what we're going to do in here, we're going to use str to search. Okay? And we're going to basically do the same checks. We're going to jump in here and say we found target starting at result. And we're going to increment str here because it is not a const pointer. Now, try to go through this thing here and see how many times you're going to loop.
I mean, it should do the same
Go
thing,
through
right?
it, and when you are done, we're going to try and run this.
All right. Let me build this real quick, but it should. Let me do the little rubber ducky test. Okay. So here we initialize a pointer, for a pointer to a const char, called str, which is I'm gonna say string when I talk about it. The contents of the string is try not, do or do not, there is no try. Then we initialize, or not initialize, we create a character called target, which is T currently. This is editable, and we probably will change it. Here we create another const char pointer called result that is currently initialized as null pointer. So it's not pointing at anything. Like, it's specifically pointing at nothing, not that it's pointing at junk data, the way that it would be if we did nothing. And then we have size t iterations. So this is going to be our counter, essentially, for how many times we go through. So, while, try not to const challenge, oh god. Result equals this, the searcher thing. So we're searching str, that's this value here, this pointer, for our target. At this point, currently a capital T. As long as it's not null, and we're making sure that it's not null pointer. So we want result to not be null pointer. So what it should do is we change here. We're assigning a new value to result, and that result that is that the first one here should result should point to this in memory. That is what it does. And then we go through, and when we find one, target is, we print it out and we say found whatever our target, found T, starting at, and then it gives us the rest of our string here. So here it'll be the whole string because capital T is the first one in the whole string. And then we increment str and our iterations, and we continue. We run through the test again. So here it's testing, it tests the string. R fails, Y fails, space fails, N, O, lowercase t fails. All of these fail all the way until we get to the capital T in there. Here it succeeds again, where we make our result and it should make our result into, or not fails. What am I trying to say? Since we're searching for it, none of these are a match for what we're searching for. Fail implies something else, I think. So then here we create our we find our new match, the next capital T, and we make our result point to that. And it's not the result still isn't null pointer. So we print another one out, and we say found T starting at, and it does this whole line, or not this whole line, but this section of the line, and then we increase that, and we increase our iterations again. So it should, in theory, be identical to the last thing that we just did, but using str instead of a pointer, or of another pointer that I don't remember what we called it in the last one. So we build it. That's weird. Why did it do that? Okay, so it doesn't do that. Interesting. Why does it not do that? Found T starting at try none. Oh. 7 panels left. I could finish this at the end of the week. Hell yeah, dude. So it keeps finding this same one. It keeps finding the second one. Why does it keep finding the second one? Why did it stop after 25 iterations? Oh, I think it stops after 25 because... Hold on. Let me count. 41. And here it's... It finds the 1, and then it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Maybe not. Why does it stop after 25? That's weird. That's strange. That's a little bit quirky. Hold on, I want to understand this. What is it doing? So we have our result. We set our results equal to this. And we're changing the value of str. Is it? So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I think what happens is these last ones, these last characters, after we get to 25, it stops finding them because it's not searching. Because first, so at str1, or I guess str0, yeah, at str0, it finds the first T, which works. At 1 through 24 indices, it'll find the only thing that it finds is this is the next one, the one for there is no try. So if I change this to lowercase, I've got a terminal. I'm kind of curious what this does. So what it should do, this one should run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. It should run 37 iterations. Let's try. Okay. So first it starts at found T starting at try not, and it's the T from the end of the word not, and then it finds so it finds that first T for the first 1, 2, 3, 4, 5, 6, 7 iterations. So 1, 2, 3, 4, 5, 6, 7 iterations. Ah, that's fucking interesting. What the hell? It's doing so because we're using STR here, because we're just iterating this one instead of what we did up here, where we were incrementing our result. Where is result? Not result. What am I saying? It was we made it oh god, where is it? I'm so dumb. Yeah, so we were iterating the pointer for result to str. I think, if I'm not mistaken, the reason that it's printing it every time is because, oh gosh, I think when we did it with just when we were checking with result instead of using str directly, I think what happened is what we're pointing to a single point in the string, a single point in memory. So here it would so like when we come here and search for capital T, it succeeds and prints it. When we come through all of these, it fails and does not. And then here it would succeed and print it again. Whereas when we're searching for through all of str, or it's not even all of str. When we search for str's place in memory, I think what's happening is it's finding it's finding a success all the way through every single one of these, and it's only after this point that it started failing and stopped printing stuff. Let's see if Gakwaya Sensei will tell us.
Yes, we're going to build with GCC. The build is going to be good. We are going to clear and run Rooster, and you see that this guy is going to loop 25 times. And this is crazy. Why is this happening? Why is this happening? What we really are doing here, we are not assigning the result in the string that we are searching at. Okay, let's try and go through this a couple of times. So the first time we're going to do our search. Okay, so we're going to search in str, and if we find our target, we're going to return the pointer to the target. If we don't find it, we're going to return a null pointer. The first time we're going to find this T here. Okay, and we're going to return a pointer to it and store that in result. Okay, so after we do this, we're going to fall in our body here, and we're going to say we found T starting at this location here. That's going to work. And we're going to increment str. Okay, notice that we're not incrementing result here. If we increment str, it's going to point to the next character, which is r here. Okay, and we're going to increment our iterations, and we're going to start a loop again. We're going to search in here, and we're going to be searching from this location here.
Yeah.
And we're going to find it.
Hell yeah.
At this location, we are going to find this T here, and we're going to return that and store that in result But the problem is that what we are incrementing here, is that we are incrementing one by one. We are not jumping to this t here. And we had a way to jump to this t by assigning the result into the same variable that we are searching in. Okay, so this is going to loop 25 times, and it is not really good.
Okay,
And
okay.
some
That makes
of you
perfect
might
sense,
try
actually.
to set up something like this, and it is really not going to be good. Try to go through this, and you're going to see the reason why it is looping 25 times. Okay, I wanted you to see this. Don't do something like this, and we are going to comment this out. The next thing we're going to see is how we can find the last occurrence of a character. And this is a really cool example. I like it. It is going to do something very practical. We are going to take a path, which is going to be an array basically stored in this input array. And we're going to strip off all the things we don't need. And we're going to hunt down for the file name from a full path. And
okay, hold on. Let's get our text, let's get our stuff exactly the same as his real quick. And then we'll see if we can understand what the hell it'll do. STD, string strrchr. We'll see. Oh, whoops. I didn't bit shift there. STD and line. We'll put in the doc reference in a sec. Character input. This is a matrix, and it's a character matrix, so it is / I don't know, home/user/hello.cpp. And then we have our character pointer. Output equals std. And then this is strr character. Okay. Input, and we're looking for the last iteration of a slash here. I can never remember which one's backslash and which one's /. They both seem fucking backwards to me. Depends on which way you draw it. If output and then it's std cout output +1 question mark std end line. Okay, and this says +1 because we want to start printing past the character found by std strrchr. We want. It's one word, totally. And let's put our little let's put our document reference here. And this is https://en.cpp/w/cp/string/byte/strrchr. The two R's here is throwing me the fuck off. Throwing me off hardcore. Okay. So here we have our character matrix titled input. We haven't initialized the size for it, but we have assigned it. This text. This is the contents of our matrix. We're looking for, so this is a pointer called output that we have assigned. We assigned it a searcher where we want it to be the last. So this is the last iteration searcher, essentially. The last thing of a character, last thing that it's done. So we want this is pointing to this, wherever this ends up in memory. I'm not sure what this output one is. Also, all right, let's see what he says.
This can be useful in whatever application you are doing. So we are going to hunt for the last occurrence of a backslash character using the strrchr facility in the C++ standard library, and you can find the documentation on this guy here. I'm not going to go there. You should really practice to go there and read what these things do. That's why I am leaving in the links to the documentation. You should go there and read, and if you have a problem, you can ask me. I will do the best I can to help you out. So this line here is going to hunt for the last backslash. It's going to find this guy here.
So that's a
and we're going to
backslash.
store a pointer to that in our output character pointer here. After we do that, we're going to say if we found something useful, if this is not null pointer, we're going to print that out. But we don't want to print starting from the backslash. We are going to use pointer arithmetic and move to the next character, which is going to be this H here. So if
And that's why we
we're
plus
going
1.
to have hello CPP printed out, because stdc out is going to print until it meets the last null character, and that's going to be after the last P here, because this is a C string literal here. Okay, we're going to build this. The build is going to be good. We're going to clear and run rooster, and you're going to see that we have hello CPP printed out here. Okay, this is really all we set out to do in this lecture. I apologize that it turned out to be lengthy. These things can
No, that's
take long
fucking
to
perfect.
explain, and I really wanted you guys to have
Made perfect
as
sense by
many
the end of it.
explanations
I was a little bit
as I could
confused at
come up
first,
with.
but it makes
We
perfect
are
sense
going
now
to
that
stop here in this lecture.
seen
The
it.
next one, we're going to see how we can copy and concatenate C strings using the facilities from C string here. Go ahead and finish up here and meet me there.
All right, give me 1 second. I will be right back so we can do our concatenation. But I need to take a quick leak. I'll be right back. All right, I'm back. Oh, sorry about that. Oh, okay. So we got how much time left on this one? I think it's like half an hour of the actual lesson. Yeah, about half an hour left. We should be able to finish the chapter today, I think. So let's keep it up.
In this lecture, we're going to look at a few more facilities from the C string library, and those are going to allow us to concatenate and copy strings over. The documentation for what we're going to be talking about can be found here. If you go there, you're going to fall on this link here, and you're going to find that C string was originally in the C standard library as string.h, but in C++ we can use it like this. We have a couple of functions. We can copy stuff, we can concatenate, we can get the string length. We have seen this, but now we're going to look at things that allow us to copy and concatenate stuff, because that's something you may want to do a lot. The first example we're going to look at is std_strcat, which is going to allow you to join strings. Again,
join
you can browse
strings,
through the documentation here and see more about this facility here, and you're going to see all about it. For now, we're just going to play with it. We're going to set up two arrays. One is going to be called dest. It's going to contain hello. The other is going to be source here, and it's going to contain world. Notice
So
that these
destination
are row
and
static
source.
arrays that are stored on the stack, and that's how we set them up here. Okay, so we can concatenate strings using the syntax like this. We're going to say std_strcat. We're going to say the destination string, and we're going to say the source string we want to copy from. Okay, so after we do this, the destination is going to contain these two strings joined together. And before you do this, you have to be sure that your destination string is big enough. And this is a problem because you have to really keep track of your destination string, and it is easy to put in many more characters that can really fit in the destination string. That's the reason many of these functions here are considered unsafe by many compilers. I don't think you can compile this on Visual Studio. It's going to stop you from doing this. Because of this way, you have to keep track of things yourself. But I am just showing you so that you know how to avoid these problems if you happen to be on a compiler that doesn't protect you from this. So we're going to append goodbye world to whatever is in dest.
Goodbye world.
Down here, if we print dest,
look, it's not it wouldn't be the first time that this video has made me have to restart my whole computer.
Don't worry if any of this doesn't make sense yet. Here is another example of how we can join strings through strcat. We have two strings and we set them up with simple characters like this. You can do this and put in your own null terminating character. This is illegal C++ code. And notice that this array is a dynamic array. It's going to live on the heap because of this new operator here. We also have a source array, which is also going to live on the heap. It is 30 characters long, so it is really long. And we're going to try and concatenate things here. But before we do that, we're going to check their length. We're going to print them out, and we are going to concatenate. The syntax is the same. You are going to say strcat. You're going to specify your destination and your source you're going to be copying stuff from, and you are going to store the result in destination here. What this is going to do, it's going to grab whatever is in source and copy it. So it's going to copy the entire thing here from source, and it's going to append that to whatever we have in destination, starting from the last null character here. So it's going to overwrite from this null character, and it's going to basically copy everything in the destination here. And if we print whatever we have in destination here, we're going to have file load, the Phoenix King printed out. And you're going to see that this is going to be the case when we hit Visual Studio Code in a minute. You can also use a version of the strcat version that is going to allow you to specify how many characters you want to concatenate from the source string. In this
that is
case,
such a fun word, concatenate.
Hello, and we have source, which is there is a bird on my window. And down here you see that we do strncat. We say the destination, we say the source, and we say how many characters we want copied from the source here. And we say 6 characters. So we are going to count from the source. We're going to say 1, 2, 3, 4, 5, 6. We're going to grab this there string with this space here, and we're going to append that to the source. And that's what we're going to get in here. We're going to say hello space and there, and that's what we're going to have printed out here if we print dest. We can also copy stuff And the strcpy function here is going to do that. And here
String
we have an
copy.
example that is going to try and drive this home for you. We have a source string, which is C++.
Okay, this is making a lot more sense in the lecture portion than the last one was, I think. I was very confused, but the last one kind of ended up making sense when I got to work on it. This is a little bit more logical, I think. I'm expecting it to just kind of be like one then the other. I don't think it's going to shuffle the letters together at all. That'll be weird.
Okay, after that we're going to jump down here and say strcpy dest3 and source3. We are basically going to be copying from source and pasting in destination here. That's what we are doing. If we print destination, we're going to see that now it's going to contain whatever we had in source. And this is how you can use these methods here. We also have a version with which we can specify how many characters we want copied from the source. Here we have a source string, which is hello. We have a destination string, which is dest4. And we are going to copy stuff. We're going to copy from the source. We're going to paste in the destination. And we are just going to copy 5 characters. What this is going to do is copy everything from the source and paste in our destination. And it is going to override whatever we have in the starting indexes in destination here. So we're going to have A, B, C, D, E here replaced by hello. And if we print dest here, we're going to have hello F printed out. This is how
it seems like a really convoluted way to do a bunch of copying and pasting.
I just come and read the documentation here. For example, strncpy here. If we click on it, we are going to get the documentation. This is going to say copies at must count characters of the byte string source.
This is actually he stresses reading the documentation and stuff, and I think there's a good reason for that. Because how many times I've heard my friends mention that oh yeah, half my job is Googling how to do something.
The destination string. So if you want this pointer, you can use it. And you can go down.
Or I'd rather not my friends specifically, but I've heard that online from people who do this for a living. It's like, oh, I used some Google foo and find a way to do it and read online.
The current project is C string concatenation and copy.
Other times it's like, oh yeah, here's a working GitHub link that has pretty much exactly what you need.
Project and put them in place. We're going to open this in Visual Studio Code pretty quick. We are going to include C string because that's what we're going to be using here. We are going to bring this up a little bit, and we are going to put in our first example here. We have 2 strings, destination and source, and you see that we tried and made sure that they are large enough to contain however many characters we want to put in. And they are row arrays stored on the stack because they are set up like this. And again, you can check out the documentation here if you want to know how this function works. And we are going to call strcat here to concatenate the source to our destination here. So if we do this, we're going to have world here concatenated to what we have in hello here. And we're going to have hello world in place. For example, if we try and print this out, we're going to try and do that. After we do the first concatenation here, let's do that. That's going to be better to show you how these things work. Okay, after the first function here runs, we're going to have source concatenated to destination here. So what we're going to have is hello world stored in destination here. The second concatenation here is going to append goodbye world to whatever we have in destination here. So what?
All right, let's get our text in order. std strcat dest source. So we'll say we'll just copy what it says. Some compilers, Microsoft Visual, I think it's MSVC, whatever the fuck, Microsoft Visual Code. Think these functions are unsafe. And truth be told, they probably are, when in the hands of a moron like me. However, we move on because I can't read. Alright, we do dest, std, and line, So this one, he says, hello world. Okay, so my understanding, actually, let's do like that. Also, didn't hold shift hard enough for that one, I guess. And then this one is std stircat dest space goodbye world. Std cout. And then we have dest, and then dest std end line. So this is fairly easy to understand, I think. If my understanding is not completely fucking wrong, which it could be, but we'll find out. So let's get this documentation in here. en.cppreference.com/w/cpp/string/byte/stircat. So the way that I'm understanding this, and it shouldn't be too difficult. So we have we initialize a character matrix called dest with a size of 50, and we fill it with the words. We fill it with the word hello and a space. Everything else in this should be initialized to, I think, zeros or nothing. I don't think it's initialized to junk data because we have initialized it a given size for it. And then we have another one. We did a very similar thing for matrix called with a size of 50. Matrix with a size of 50. And we filled it with the word world and an exclamation point. So what we're gonna do is essentially, this is the concatenation thing. So as a string concatenate, which should just essentially mush them together. So if my understanding of this is correct, we're taking dest and then we're putting src at the end of it. And I think the way he explained it, I think it's supposed to overwrite the null character. So it shouldn't overwrite this space. This space should stay. But it overwrites the null character that we don't actually see in this because we didn't write it all out individually. And from there, we put in the new things. So here we have, and then here it prints it out. So we print out dest, and it should print out the whole thing as hello world. So the text within world has now been put into dest. I think this is still its own thing in addition to this, but I guess we'll find out later on. And then this one, we're taking dest that we did before. We have hello world in it, and again we have a null character at the end of hello world. And so what it's doing is it's overwriting that null character with this space and then appending goodbye world to it. And we should have some number of characters still left over. I don't think hello world goodbye world is 50 characters. So anyways, that's go to new terminal. And then we have here where we print out all of the new text. So let's give this a little run. So let's run task, G++, and then we will run rooster. So here, empty line in this, hello world, and then goodbye world. Well, hello world and goodbye world, but you know. So it works. It works as expected.
What we're going to have printed out is, if we
that's
print
good.
that, of course, is hello world and goodbye world. Okay, we're going to have this printed out. Let's try and run this and actually make sure that that's the case. And then we're going to see how these functions can be unsafe for some compilers. We're going to build this with GCC. You see that it's going to go through. And if we run this, we're going to have hello world, goodbye world printed out. This is what we expect. And again, this function here, strcat, is going to have whatever you have in source, and it is going to append that to whatever you have in destination.
So if we
And
switch
for
the
this to
order,
work, you have to be sure that the destination is modifiable. For example, if it was an array of const car, let's do that and show you the compiler error. We should get a compiler error because now
that doesn't work because destination is no longer
modifiable. It is an
modifiable.
array of const characters and we can't modify it. So be sure
I think if we
the
swap the
destination
order
array
of these
is
two,
modifiable,
it
and in
would
this
do
case it is.
world
Okay,
hello.
please note that some of these functions can be treated as unsafe by some compilers, but I tried this out on both on GCC and the compiler from Microsoft, and they work pretty well, so you can try them out here. To prove that, let's go and try and build with the compiler from Microsoft. We have it set up here. So we're going to run the task to build with MSVC here.
I'm just going to let him do that because I don't really see a need to do it.
The build finished successfully. And if we go in, we're going to clear and run Rooster, you're going to see that it is going to do exactly the same thing.
Yeah,
But
it does
some
exactly the same
compilers
thing
might
and it
give
creates a
you
bunch of
warnings or errors
bullshit.
if you try to do something like this. And the reason is you really have to be careful using these functions because if, for example, destination array is not large enough, you may do some crazy things running over the bounds of your array, and it can be really bad. For example, if we try and make destination array here, for example, a size of 3, it is possible to do that. And you see that we get a warning from Visual Studio Code. And if we try and build this with GCC, let's try and remove the garbage.
Does it actually let it work?
Visual Studio.
There's no way it lets it work, right?
Clean, we can try and build with GCC. Let's do that. Our compiler, we're going to choose GCC. And you're going to see that it's going to give you an error.
Okay,
it's going to actually protect us from doing something like this.
You're not able to do it.
In some cases, some compilers are not going to stop you from doing this.
That would be
any compiler
bad.
that really respects itself is going to have these safety checks in and is going to protect you from doing something crazy like this. Okay, this is how you can do concatenation using strcat like we did here. Let's try and build and see that now we are building fine because I don't like these red lines here. The build is good and we are all fine.
Okay.
Now I am going to comment this out and we're going to see another example of how we can concatenate stuff. We are going to go down here. Let's bring this down and hide this. And we are going to put in our simple example. Exactly the same thing we saw in the slides. We have two characters.
Okay, so this one has a lot more text. So cout, std, end line. Oh, oops, I didn't hold shift hard enough. Let go of it one too early. And then we go std, cout, more std, concatenation. And then we do std, end line. And then it's, so we have our character pointer dest1 a new, so we're working with the heap again. This is something that I still don't quite understand. Like I understand it conceptually, I don't understand how it's important. I R E L O R D, and then we create our / thingamajig, the null character that I always forget that that's what it's called. Character, another character pointer called source1, which has the text new character. It's an array, a character array of 30. And then we have dun 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 the oh god, okay. Hold on, I need this to be P, and then it's and it's supposed to be Phoenix, so I'm going to spell it correctly. links. And then we do another space. This is so awkward. And then we do our / null character. And like so. Okay. So now we have our dest1, source1. These are both pointers. They're pointing to the heap. I don't quite know why we're doing it this way. I'm sure there's a good reason for it. Just to use it, I guess, would be a good enough reason, probably. Note to self. What is our note to self? Describe what's going to happen in std concatenation before you do the cat. Source is going to be appended to dest, and the process will start by overriding the null character in dest. Yes, okay, so yeah, so we have our null character here. So we'll start by, it starts by appending that. So it creates a, if that's the case, then we might want to create a, another space between that and the comma. So we have how many things now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think we're good. As long as it's not more than 30. We're more than halfway through and we're at like 10, so. The way that this is going to work. Also, that needs to be, I want that online. So we do std string length dest1. And then we create we print out the length of the string. str length dest1. std end line. And then we have another one called, alright, this one's testing for the source, std str, I say the source, but it's for source 1. Testing the length of source 1. std str len source 1 end line. So what this is doing is it's reading out the length of each of these, so we know how long each of them are.
Structure arrays. They are dynamic arrays, but we initialize them with characters like this, and we make sure to put in our null terminator. We have our source string, which is going to say the Phoenix King, and it's going to have a terminator here. And what we're going to do, we're going to take source and concatenate that to our destination. So what is really going to happen, we are going to override the null terminator here, and we're going to start pasting in things from source here. So after the concatenation is done, what we are doing here, we are concatenating source 1 to dest1. We are going to have firelord, the Phoenix King, stored in our destination string here. And notice that we made sure that it is large enough to contain our characters here. And if we print it out, we're going to have the thing printed out. We can try and...
Hold on. So we got the rest of the text now. The holy texts! Okay, so then we have std cout, and it's just concatenating. I don't know why we are doing it like this, but we do. I keep doing that. And we do string concatenation, and we do dest1 source 1. So the way this is, yeah, we'll run through all of the text after I get these last couple lines printed. See out, and then it's std string length dest1. So it should get a new string length because it'll be no, it'll have this. It should be the same length, right? Std string. No. Hold on, I'm an idiot. Let me explain my mistake in a second. I'm getting myself confused, thinking too much. Dest1, and then it prints dest1. Okay, so when I was thinking string length, for some reason I was thinking size of, which is very similar but is not the same thing, especially when it comes to these. So even though this is a character array of 30 characters for both of them, it should only be it should only count how many characters we actually have written out, and it doesn't count the null character as one. Okay, so what we're doing here: empty line, more std concatenation. We create a character pointer called dest1, which points to a character array that is 30 characters long that contains Firelord, Firelord, and also a null character. Then here we have another character array, or another pointer, I should say, because these are not the actual character arrays themselves. This is a pointer to dest1. This is called dest1, and this one's called source1. This one is also pointing to a character array that has the contents of like it's got a comma, a space, and then the Phoenix King, and it goes all the way out to a null character. So this stuff is just initializing. None of this stuff is getting printed. So then here we're printing out std string length dest1. So we're just printing out the string length. So this one should be 1, 2, 3, 4, 5, 6, 7, 8. It should be string length of 8. I'm not going to count the second one because it's much longer. Or it's not that much longer, but it should print out string length dest1 8, string length source1, and then whatever the string length of this one is. This one we're printing out the text concatenating, and then here we concatenate. So we have our dest1. So Firelord is going to still be the first. This is our destination, as it were. This is the first one that we're going to paste our stuff into, essentially. And then we have the second one, source, that we called source1, where we're going to put all of these characters in. So we still haven't printed these things, not yet. We're just creating, essentially overwriting dest1 with the new stuff. Or we're concatenating the two, but we're at it since we still use dest1. I'm basically saying it like we're pasting source1 into dest1. So then here we look at our new string length. We're creating a new string length for dest1, because we've concatenated the text. And then here now we actually print it, and here is where it should say Firelord the Phoenix King. So let's run this real quick. Run task. And let's see if my predictions are correct. So empty line, thing for us, string length 8, String length, the other one, 19. We concatenate it. Our new string length is 27. And then here we have Fire Lord, the Phoenix King, exactly as predicted. Now, I think his is going to be a little bit shorter. I think his has maybe 25 letters. Because I think I added a space in here that I don't think he has, and I added the O in the word Phoenix. So that's my prediction for what's going to happen next.
And build with GCC, that's going to go through. Let's bring this up. The build is good. If you go down here, the build is good. We're going to clear and run rooster. Okay, this is the output here.
Look at that, dude.
The destination is 8 characters long. If we count 1, 2, 3, 4, 5, 6, 7, 8. Remember, strlen doesn't count the null characters, so this is what we expect. 8 characters. The source is going to be 17
Oh my
characters.
god, dude.
If we count all this, that's what you're going to get. And if we concatenate them, now destination is going to be 25 characters long in the eyes of strlen. And you see that we print the destination, and it is exactly what we expect. Fire Lord, the Phoenix King. Okay, we're going to comment this out. I just wanted you to see an example of this. And the one thing
I love how he goes through it super quickly, but I spent like fucking 15 minutes typing it out and going through the text and making sure I understand it's correct.
The last null character. Okay, so this guy is going to be overridden by the comma here, and we're going to start inputting stuff, and that's what we're going to see here. Let's comment this out because we want to move on and show you a few other examples. Okay, the next thing we're going to look at is a new version of strcat that allows you to specify how many characters you want concatenated from source. For example, here we have two strings, destination and source, and here we are basically saying I want to concatenate 6 characters from source and put them at the end of the destination here. And what it's going to do, it's going to grab 1, 2, 3, 4, 5, 6. It's going to grab this entire thing, and it's going to append that to hello, and we're going to have hello there stored in the destination. And the return value is going to be a pointer to destination 2. And how do I know the return value? Well, I know that from the documentation. If you go in your favorite search engine and do stdstrncat, and you're going to see a link here. If you click on it from CPP reference, it's going to give you everything you need to know about this function here. It's going to append.
Yeah, it's just like all of the other stuff.
Destination.
It's exactly this link, but with an N.
Are going to be copied. So the third parameter here is going to be how many characters you want copied and pasted into our destination. And the return value is going to be dest. Okay, if we try this out...
Alright, let's, real quick, let's get the text sorted. Alright, and then... I like how he has the text as there is a bird on my window, and you can literally hear a bird in the video. That's actually awesome. Okay. So we do... You can even use the returned pointer immediately for printout. This is a oh, fuck me, dude. Pattern you'll see a lot in C++ code out there. And we have std cout, std sterncat, and dest2 source2 6 std end line. Checking back while I do some vocab. Nice. How's your Japanese going? I am having a whale of a time with this coding stuff. It's actually very interesting. Okay, so here we have... I for some reason I thought I was down here. I'm up here. So then it says, or you can do std sterncat separately and print at dest2. And this is std sterncat dest2 source2 6. And then we have std cout the concatenated string is dest2 std and line. There we go. I didn't do the colons for some reason. I'm going through all the N4 vocab and writing down what I don't know. Nice. Good for memorizing it for later. Okay, so the way that this is done, we have our stdc out, we create an empty line, we're saying we're doing start and cat. Like we do with all of these things. We have an empty line and then essentially just something to explain what we're doing for ourselves. We have a character matrix, size 50, called dest2. What we've put into it is hello, and then I think everything else is just like null characters. I think that's the way that the character arrays work. Then we have another character array called source2 with a size of 30 that says there is a bird on my window. Makes perfect sense, right? So then from here we take this code. So this is we're putting something in the terminal here. So what we're doing is we're looking at our if my understanding of this is correct, because we're putting this in the terminal, this is immediately, so dest2, and then source2. So hello, and then we're going to have a space, and then with this 6, that makes me think it's going to be 1, 2, 3, 4, 5, 6. So it should just say hello there. There is a bird on your window. The bird flies away. There is a turd on your window. Yeah. Yeah. Hello. How you doing, Walk with Technology? And then for this part, so this one I think does the same thing. This one should do this something similar to this. So I think, it should just do the same thing. So here we create the new, we do the concatenation, and then we just print dest2. I'm a little bit curious whether when we print this whole thing, when we run this, I'm thinking what'll happen is it'll say hello there. Like the first one will say hello there because we did it here, but I think because we've already done it once, it should when we do it this second time and then print it again, because we have enough space in this character array, it says hello there. Let's give it a shot, shall we? Hell yeah. Understood.
We're going to see hello there printed out. We're going to print it out directly, and we're going to print that out using the destination pointer that is going to be returned from this guy here. So if we try and build this, we're going to build with GCC. The build is going to be good. We're going to clear and run rooster, and you're going to see that we have hello there twice here, and this is exactly what we expect. We are going to comment this out, and we are going to go down and look at strcpy. I should say strcpy, which is going to copy stuff from the source and paste those in the destination.
Okay, and then this is, oh, whoops. Whoops-a-daisy. Oh, that's also the wrong button. Wow, I like forgot how to push buttons. Okay. Then we're gonna do std cout, std end line. So this is again empty line, std cout, std ct or strcpy. So that's string copy. And then we do std end line. All these N4 Japanese words are making me feel like a big girl. Hell yeah. Source 3. We're assigning the source. So source 3. Oh, okay. This is going to be a little bit weird. Let me type this out real quick. is a multi-purpose programming language. And we have create another pointer, dest3. First time I see your video? Well, I hope you enjoy it. New character. And then we do std string length strlen source 3. Oh, whoops. Source 3. And then we +1. Okay. So +1 for the null character. Which country you are? I am an American. I have been American my whole life. There was a while where I was also Norwegian, but I don't think that's actually the case anymore. std str copy dest3 source 3 std cout, and then we have our size of dest3, size of, let's see, dest3 std end life, Jesus, onion std cout std strlen dest3 std strlen dest3, and then we do end line std cout dest3 std end line. So I don't think this is quite the end of this one. All right, so here, empty line, and then another thing that's just for us. I don't know. I kind of wish if the purpose of this is to tell us something, I feel like we could say something more descriptive than just the thing. So here we're creating a pointer, a const char pointer, called source 3, and it points to a string that says C++ is a multi-purpose programming language. We also created a character pointer called dest3 that uses the heap here. So we've created a new char with so it's a new character array with a size of that is equal to the string length +1 of source 3. And we do the +1 because, and it says here, +1 for the null character, because string length does not actually take into account the null character. It will literally, it takes exactly all of these characters. And when we do this, there is an implicit, fucking, what is it called? An implicit one of these numbers. And we don't use it if we don't use it when we have strings like this. So then here we're going to copy the contents of dest3 into source 3. Is that right, or are we doing it? Because that's the way it's worked with all of them, all the other ones so far, is that it's been like, okay, the one on the left is the one that remains, is the one that will be changed, and then the one on the right is the one that is doing, we're doing something to this one. Oh, no, yes, that makes perfect sense, actually. I had these reversed in my head. So we're gonna copy the contents of source 3, C++ as a multi-purpose programming language, into dest3. So then, so at this point, the contents of dest3 should be exactly the same as the contents of this. I subscribe to your channel. Appreciate it, man. Thank you. I hope you enjoy your stay. I hope you enjoy hanging out and watching some vids. I haven't uploaded a proper video in a while. It's mostly just VODs. So then we go with our dest. So we have the contents of dest3 is now equal to this. It's the same content. So then we go our size of dest3. This will actually give us the this should give us exactly the same or not exactly the same. This should be functionally no, this should be exactly the same as this value. And then this, so this is basically just printing out this, whatever this value ends up being. I don't feel like counting all of the characters here. And then this one is printing out std string length dest3. So this one should be this one minus 1. So that it should be whatever the value here, it should be the same here except 1 fewer. And then this one actually prints the line, which is this. So let's run task, G++, clear, run. So size of dest3. Oh, no. I'm a silly Billy. Dest3, because it's a pointer, is always 8. Its size is always 8. Okay, yeah. And then the string length for dest3, that's 43. That's the number of characters that we have in this. Okay, yeah. That was a silly mistake on my part. This is always going to be 8. It's a pointer, so it's always 8. The name kg must be localized as pound for American audiences. Why? Oh, god damn it. Fuck you. That's a terrible pun.
And one thing you should know is that the copy is going to happen starting from the start of the destination array. Here we have two arrays. One is called source3, the other is called destination3. Destination3 is set up on the heap using the new operator, so it is a dynamic array. And you see that we make sure that it is the same size as the source. We are using strlen to figure out how many characters we have in here. And remember that strlen doesn't account for the null character, so we are adding 1 to account for the null character. That's what we are doing here.
Right.
And after that, we are going to do std strcpy. And what that is going to
Hi.
do
Hello,
is copy
Ibeck.
stuff from source to destination, character by character. So we are basically going to have this guy pasted into destination here. And if we print things out, we're going to see that destination contains the same thing as source here. If we build this with GCC, let's do that. The build is going to be good. We can clear and run rooster, and you're going to see that the destination has exactly the same thing we had in
exactly
the
the same
source. And if
text
you need to copy
as
stuff from
intended.
arrays, strcpy is going to be very helpful. We are going to comment this out because we still have a few things we want to see. So let's
more stuff.
Comment this out. We are going to go down and
every
see
single
that we
time
can also use
we get another
another
example
version that allows us to specify how many characters we want copied from the source. Okay, in this example here, we are using std strncpy, and this n here means that
so the
we can
n is
specify the count
specifications, huh?
of characters. We do whatever the current function is doing here. Okay, so we are specifying I want 5 characters copied from source, and I want those pasted into destination here. That's what we are saying here. And the source is going
There's
to
a word
contain
concae,
hello,
which means relation
destination is going
connection,
to
but if you
contain
make it
world,
into a verb,
and
it
the
becomes
copy is going
sex.
to happen
Nice.
starting at the first index here. So we're going to have hello override whatever we have in A, B, C, D, E, because that's 5 characters here. And dest is going to contain hello F if we print it out. Let's build this and see if that's what we're going to get. We're going to
Hold on. I want to do this too. I want to put my thingamajigs. D, E, F, and then we use our null character. Okay. And then here we have std cout dest4. Oh, this is supposed to be. And it's like so. There we go. And then we actually print dest4. And then it's std end line. Std cout copying std end line. Oh gosh. Okay. Like so. And then we have std strn cpy dest 4 source 4 5, and then we have std cout dest 4 dest 4. All right, so we're gonna do. I'm gonna try and do this one as like a lightning round. Make sure, because I think I understand what's going on. Okay, so this one we have empty line, strn copy, and then we have constant character 4. So obviously pointer, creating character matrix, hello, and then we have the contents of this one. We have not initialized a size, so it's just going to take whatever we put inside of it, and we have 1, 2, 3, 4, 5, 6, 7 with the null character. So then dest4 will just print out the contents of this, and it'll just be A, B, C, D, E, F. And then we go copying, and it'll copy this, and then we print the. It'll copy source 4, which we put here. It's going to be hello, and then here it'll say dest4 now prints hello. So run task g++, clear rooster. Oh, hello f. Yeah, I don't know. I know how to count. 1, 2, 3, 4, 5. Yeah. So we're copying the first 5.
Build with GCC, the build is going to go through. We are going to clear and run rooster. And
Yep.
you see that
hello
that's
F.
exactly what we have here.
Okay.
This is how these methods work. There are
Dancing
many
on
more
VS
functions
Code.
you can use from the C string library. And again, if you want to see a list of them all, you can go through your favorite
we
search
can go
engine
we can
and
go
search
to
for C string.
cppreference.com and find
Let's try and do that. Okay,
find our favorite thing.
We can click on that.
Look at that, and it has all of these different types, everything that we can possibly want to read documentation on.
Function, you can click on it and see what it does. And if you go down, you're going to find even an example of how you can use it. For now, we are going to stop here in this lecture, and this is actually going to be the last lecture we see on C strings. In the next one, we're going to start and look at std string, which is a compound type that makes working with strings very easy in C++. Go ahead and finish up here and meet me there. In this lecture, we're going to start.
Right, so let me look real quick. I think this is the last part of the chapter. Introducing std string. Okay, so there's another 10 minutes of this video or another 12 minutes of the lesson today. So we're gonna go ahead and finish it out, I think. I mean, we've already been going for 2.5 hours. What's another like 20 minutes to 30 minutes?
And learn about std string, which is a type that is going to make it super easy to work with string data. We have seen many ways we can work with character arrays by now. We can use row arrays, we can point to them with pointers, we can even allocate arrays on the heap. But all
yes, we
these
can.
character arrays had a few problems that are really a pain in the neck to deal with on a daily basis. One of those problems was that you had to keep the size in check. You have to know how many elements you have in the character array.
Yeah, that's a little bit of a pain.
Defining the bounds that you can work in. If you go over bounds, we have seen that can cause crashes of your program.
Well, we didn't actually see that, but it is.
We had really
we have seen crashes before.
Of the null character. If we don't have it in place, we're going to have problems when our string is printed out. And it's really annoying to always have to think about these little details when all you really want is to store a string. So C++ offers a high-level type that we can use, and it is going to hide all these little details underground, and all we have to do is put in our string and use it, and we can be on our merry way and do whatever we want to do with string data in our C++ application. So that's
That
what we're
sounds
going to do. We're
convenient.
going
I
to
like
have a
that.
type that is going to wrap on top of the ugly array complications
Shakai
we
means
have been doing on
society.
character arrays.
I
We're
guess
going
the
to call
Japanese
that
say to
std
have
string,
relations to.
and we're
Oh my
going to
god.
be able to do many of the things we were doing with C strings, but in a much better way. We can concatenate, we can search, we can copy, we can do
Is
all
that not
kinds of
what this has
gadgets
been
that
the
we
whole
need,
time?
but it's going to be in a way that
Like
you
these
don't have to worry about
STD
these little
things?
details about array bounds, the null character. You're going to just use it for what you want, which is storing character or text data. Okay, so that's what we're going to be doing in the next few lectures. We're going to be learning about std string and how you can use it in your C++ applications, and it's going to make your life a whole lot easier. We are going to stop here in this lecture. In the next one, we're going to see how you can declare, initialize, and use std string in your C++ application. Go ahead and finish up here and meet me there. And this lecture,
All right.
we're going to see how
Let's
you can
use this.
declare
Let's
and
use this thing.
std string in your C++ applications. std string is a type that is going to wrap on top of arrays and give us a really nice interface that we can use to store string data without having to deal with the ugly little details like keeping track of array bounds, remembering to keep in check the null character, and things like that. To use std string, you will need to include the string library, and after you do this, you can declare and use your strings.
Oh,
Just
that's
like
a lot of
this.
text.
Here we have a series of examples just to get you started on this. You declare your strings just like you declare any other type. You specify the type on the left. The type is going to be std string.
Yep.
By the way, you'll have to remember to use std : like this, and we will have a chance to explain why in a few chapters ahead. But for now, we're just going to think of std string as our type. So we declare a string type, we call it full name, and we can leave it like this uninitialized, and it is going to be an empty string. We can also put in our string and initialize that with a string literal, and it is going to
I wonder if
work.
string will
Another way
like
of
create a
doing
little
this is
thing that lets us
initializing a
see
string
it,
with another string, which
or
we
if
are doing down here.
because
You can also
it's
set
different
up
from
another
C out.
string and initialize it with part of another string literal. So for example, message here is going to be hello, and it's only going to grab 5 characters from this string literal. This is something you might want to do if it makes sense for whatever application you are doing here. We can also initialize our string with multiple copies of one character, and this is the syntax to do it. You say the name of your variable, you say however many times you want the character repeated, and you say which character it is, just like this. We can also initialize a string with part of another existing string. So for example, here we have saying hello, and it is initialized with part of what we have in greeting here. So we're going to start at index 6, which is going to be 0, 1, 2, 3, 4, 5, 6 on the W here, and we're going to grab 5 characters. So 1, 2, 3, 4, 5, and that's what we're going to use to initialize.
Oh, that's
saying hello here.
That's
and
weird.
If we print it out, we're going to see that this is going to be exactly
this one. I think is going to be kind of weird for me to understand because we have here starting at index 6, so we have to make sure we don't start. We start from 0, 1, 2, 3, 4, 5, 6, and then it takes that character and then the next ones. That's going to be really weird for me to try and understand and like remember and get used to.
You can see that it is easier. You don't have to use pointers. You don't have to use arrays. And the best part is std string can grow automatically if you happen to store in more characters than you initialized it with in the first place. And that's pretty cool. So now
that sounds very convenient.
To Visual Studio Code and play with us.
All right, let's use this a little bit.
Okay,
hopefully this shouldn't take too long.
Folder. The current project is declaring and using std string, which is what we are doing here. We're going to grab our template files pretty quick, and we're going to go in and store in the files, and we're going to open the folder, and we're going to include the string library. Let's do that. Okay, this is how we do it.
We don't have that.
And
we just have C string.
That we have it
Hold on, let's add that real quick.
Project, we can start declaring and using std string types in our C++ program. We are going to go down and put in the code to play with this a little bit.
That's a lot of text. What the hell? std, oh god, string, full name. That's an empty string. std, string, planet. Oh, what the hell? That is not what I wanted to do. Planet, What are you doing? Stop that. Planet. Fucking, oh my god. I learned Python, but I don't know how to connect Python to Android Studio. Oh man, I've never done any coding before except for these streams. Like I like technically I have some like high school JavaScript stuff, but that is that is old tech for me now. I have no idea what that's gonna how helpful that's been to my understanding of any of this. Sky is blue. We can worry about the other stuff that it has. String preferred planet std string message and then hello there 5 std string, and this is weird message for e, and then it's std string greeting. Let's just start with the strings because the C out. So I'm kind of like, we know what C out is, right? Like, unless I'm like going insane and we didn't actually need to, and I don't actually know what's going on with that. So here, oh whoop, this is greeting. Here, I'll just change this to saying hello, and then we'll make greeting real quick. String greeting, and this is hello world. Good morning, sunshine. The earth says hello.
You can declare an empty string like this, and it's not going to have anything inside. You can declare a string and put in a string literal like we are doing here. And std string knows how to handle this, so it's going to store it inside using a character array. But we don't have to really worry about that character array is going to work. We're just going to use std string here. We can set up
Good morning from
string
India.
using another string in our initializer like this.
Welcome.
We can also use part of
It's
a
like
literal to
6
initialize
p.m. where I am.
So for example, this string literal here, we're going to grab part of it, and we're going to grab 5 characters and use those to initialize our message std string here. And this is pretty cool. We can also use multiple characters to initialize a string like this. We say however many copies we want of this character in this string here, and it is going to be exactly what we want. So it's going to be 4 E's in this weird message string. And we can initialize a string with part of another string.
Nice.
And this is really cool, and it may come in handy in many applications. So for example, here saying hello is going to contain world here, and we are saying that this is what we want by saying we want to start at index 6 in this string here. So if we go 0, 1, 2, 3, 4, 5, 6, this is going to be our character at index 6. And from this index, we're going to grab 5 characters. So we're going to count 1, 2, 3, 4, 5, and that's going to be what's stored in this string here. And if you don't believe me, we can print all these things out, and they are going to be exactly what we expect. And by this, you can even see that we can print std strings using std-cout very conveniently like this. And this is very cool. Okay, so we can try and build this with GCC. The build is going to go through, so we're going to bring up the terminal so that we can run this. And we're going to clear. And let's see what we see when we run Rooster here. So we're going to print the full name. The full name is empty. Okay, so
is it just printing each of these?
It is empty. We're going to see planet. Planet is this thing we have in here. Planet where the sky is blue. So this is what we expect. We can say preferred planet and put in the text for the planet here. So we're going to get the same thing here. And if we have a message and say hello there and grab the first characters in this string literal, message is going to say hello, which is
3:17 a.m. here. Oh my gosh.
Let's go down and
that's
look
early.
at weird
That's
messages.
early.
Early
in the morning.
What we have here. And we can initialize
it's almost 8 a.m. for you. Jeez.
With part of what we have in greeting, and we have targeted.
You guys are up early.
String here, And it is what we see here. And this is pretty cool. The good thing...
All right, let's look at these full name. Let's look at these COUTs. Let's get this. So planet, and then it's planet, std, and line. And then we do our cout, and we have preferred planet, and then we do preferred planet, and then we end our line. And we have cout message, and we have message, and we have end line. I think it's just printing out each of these things, which is kind of weird, but also not too strange. Weird message, weird message, std end line, std cout, greeting, std end line, and then we finally have saying hello. Hello. Saying hello. std end line. Just spreading the word that the demo for Final Fantasy 16 is on Steam. Getting my tired ass back to sleep. Oh, sweet. Well, get some good rest, man. That sounds interesting. I haven't played 16 at all, I don't think. All right. So, I mean, this it should print exactly what it says here, because it's very... I mean, these are strings. Like, all this really is just naming a string, and then we can call it later, which is just what we're doing. Other than that, it's basically like the COUTs that we've been doing. Good luck. Appreciate it, man. Thank you. So let's go ahead and run task. Clear rooster. Whole night I use internet. Nice. I've been there before. All right, so full name. We didn't initialize full name with anything, which, duh. Planet Earth. Preferred planet. Yeah, I misspelled that a little bit, but oh well. I misspelled it. Oh, I only misspelled it here. Here. Boom. There we go. Fixed. Message, and we just made our message hello. A weird message, greeting hello world, which we created by using greeting. Or we created by using wait, what? Oh, no, greeting was hello world. And then saying hello, we just printed the word world, because we went to index 6 and then printed 5. We probably could, I think if we change this to 0 and then print 5, it should be 1, 2, 3, 4, 5. Then it prints then it would be fine, or it would print the word hello, but as it is, it's like
The thing
that.
about std string, however, is that you can store in more characters than we initialize this guy with.
Yeah.
So for example, here we have this message here, but we can say planet. Let's go down here and say it. We're going to change std string at runtime, so we're going to say planet, and we're going to assign something to it. We're going to put in whatever was in there first, and we're going to paste that in multiple times. Let's do 3 times. I think that's going to be enough. Or we can even bring this back so that we see the entire thing here. Doesn't really matter. All we want is for this thing to be larger than it was initially declared in planet here. So we're going to remove these quotes because they are making things ugly for us. And now it's going to be a valid string. Let's wait for Visual Studio Code to
And then we can just print it again.
And it's going to remove these squiggly lines. Now we are good. std string is automatically going to take care of the
Hantai means antagonism. Better not get that confused with another word.
We don't have to worry about that. And if we print planet now, we're going to see the same details and taken care of. Okay, this is really cool, and it makes it super easy to work with text and string data like you see here. So let's build again so that our changes are reflected
And
in
then it
our
should
output.
do.
We're going to clear and run rooster, and we're going to see
Look at
that
that.
planet is now really large. Okay, we can change this
Look at
thing,
that.
the size
It
of this
works
thing at
exactly as
runtime, and this is
advertised.
something we
Nice.
couldn't do with arrays. So for example, if we go down here and use a row array to do something like this,
Yeah, because
this code
the
is going
arrays.
to run, but try to think about what is really happening here. We have an array which contains this text here, and it is pointed to by this const char pointer that we have. If we try and do an assignment like this is really going to be to make it point to another character array in memory. And this piece of memory here is basically going to be wasted because we think we have our planet string in here. This is not the case with std string, because std string, when we do something like this, the initial memory that was allocated to store planet here is going to be returned to the operating system.
That's actually very convenient, very good for
this new thing.
efficiency.
So the waste we're doing here by just leaving this in memory and not using it is not being done.
I was sleeping.
So
well, we're almost done, lazy.
Output, but inside in how our memory is managed,
like literally like 2 minutes from being done.
In that the memory that was used to initialize this guy is not wasted out. Here with array, what we really are doing is just make this planet pointer point to another string and to be wasted in memory. This is what we are doing here. And we can avoid that with std string. In this lecture, we're going to learn about the...
Hey, yo, you can't just end it there. You're supposed to say, go ahead and finish up here and meet me there. What is one definite... Wait, that's not actually on here. Oh, wait, yes, it is. It's the first part of the next chapter. Okay. Well, that's the end of the chapter. That is the end of chapter 10. That puts us at 14 hours into the video total. So we're at we're almost 3 hours into this stream. But I think we got we did a lot of stuff with characters in these past couple days. Lazy is so lazy. We did a bunch of stuff with characters today. I liked it because it made me feel smart. Like I was able to look at it and be like, yeah, I understand that. That makes perfect sense. You know, not even a little bit confused. You know, like I was a little bit confused on one of them at the beginning, but then like after we got working on it, I was like, okay, that clicks. That makes more sense now. But as it is, I mean, so far it's been pretty good. The next chapter is going to be on functions. And it's the next chapter is 2 hours long, and I mean this one was like we did like 1 hour of video, and we've been streaming for 3 hours now. So what I'm going to go ahead and say, I appreciate you guys coming to hang out with me today. Let me get over here. I appreciate you guys coming to hang out with me today. It's been a lot of fun learning. I'm not well. I'm hoping to apply this stuff to game dev later on. No problem, Bragg. Anytime. Yeah, fun C++. Yes, it's been a lot of fun. It's been a lot of fun learning all this stuff. It's just it's just a little bit hard. You know, sometimes every once in a while I'm like, man, I really wish Lazy was here. You know, I kind of wish I could have somebody who could explain this to me. I'm just gonna make you feel bad about it. So am I. All right, I'm gonna get my. So we're on. I'm writing my chapter down. So we're on chapter 11. Functions. And we'll put our timestamp 14 hours, 12 minutes, 50 seconds. Man, once we get into once we get through this, it's going to be really interesting stuff. I'm kind of curious how it's going to go. But anyways, again, I appreciate you guys coming to hang out with me. It's been a lot of fun. I'll be live again later tonight, but that'll be in 5 hours at 11 p.m. Eastern, and I'll be playing some Vigi games. We'll be playing some Tron Bonne, The Misadventures of Tron Bonne on the PS1. And it'll be it'll be a good time, I think. You just woke up? Oh man, you and Lazy both. I hope C++ went well. It did. It went pretty all right, pretty good. I was able to understand most of the stuff, and I was able to walk through most of the code that I was somewhat confused by and understand it better. Concatenation isn't too difficult. But again, I'm gonna hop off now. Probably get some food. Do some other stuff in the meanwhile, and then we'll be back in a few. Later, guys. Have a good one. Bye.